Hello. In this video, we're going to do some practice questions for the TSI for my Algebra 2 class. The TSI is the Texas Success Initiative, and we're going to be taking the most recent practice test available from College Board. I've uploaded this in Schoology, so that's kind of what this video guide pertains to. I'm just going to go through the solutions of these 20 questions from this practice test. In this document, there's some general information about the TSI. I've talked about a lot of this in class, but just a basic overview, there are 4 sort of domains or regions of mathematical knowledge that this test covers. That is quantitative reasoning. That's just your kind of numerical intuition, being able to reason with different quantities. Algebraic reasoning, which is the stuff you learn in Algebra 1 and Algebra 2, or maybe some 7th/8th grade math, a little bit of that. Geometric and spatial reasoning, this can range from pretty much anywhere in your span of education. I mean, this covers this spatial reasoning and geometrical reasoning. I mean, that could be anything from first grade to now, all right? It's basically just how do you do with the visual pictures, and can you think abstractly? And then the last is probability and statistics. Now, this is really basic probability and statistics. It's usually just kind of like, what's the probability of me flipping a coin and getting heads 3 times in a row, right? Something like that. And that's kind of stuff you cover in middle school. As well as statistical stuff, so that's like mean, median, mode, range, right? Those nice words. And the last thing to note is the use of calculators. On the TSI, you will not be provided a physical calculator. You will need to use the calculator that is built into the online test. Now, that online test is going to include a basic calculator, maybe one that can do square roots, and a graphing calculator. For some questions, meaning not every question is going to have access to these types of calculators. If the calculator is type as determined per question, so you'll either see that icon or you won't. Okay? All right. Let's go. Let's try this out. Let's do these questions. Okay, so we got, oh boy. Mr. Spake going to have some fun here doing 20 questions. All right. Let's start with number 1. For each of the following questions below, choose the best answer from the 4 category choices given. By the way, I'm probably going to do multiple strategies here. I'll show you, it may be on some questions we could think or reason about the multiple choice responses, and then I'll also show you about how we can just get it by hand. Okay. So number 1, if there are 2.2 pounds in 1 kilogram, how many pounds are there in X kilograms? Well, to figure out the number of pounds per kilogram, right? What you're doing is pounds per kilogram times the number of kilograms. That's essentially how you find the number of pounds in however many kilograms there are. And that's because these units would cancel. Oops, I meant to do the little highlighter, not the highlighter, the laser. This kilograms would multiply with that kilograms. Those units would cancel, and I'd be left with pounds, only pounds. So if I think about pounds per kilogram, well, there are 2.2 pounds per 1 kilogram times X kilograms, which essentially equals 2.2x. All right, and so it'd be answer choice B. That's a simple unit conversion question that should be pretty basic to do. Okay, let's move on. Number 2. All right, the most exhausting thing about doing this is going to be reading the questions. Okay. The bar graph above shows the number of customers who shopped at a store Monday through Thursday of 1 week. If the number of customers on Friday was 1/5 increase from the number of customers on Thursday, How many customers shopped in the store on Friday? Okay, so we have a bunch of information here about Monday, Tuesday, Wednesday, Thursday. We only care about Thursday. So I don't care at all about Monday, Tuesday, Wednesday. I'm just looking at Thursday. Now, do notice, right, this thing goes up to 4, but this is the number of customers in hundreds, so it's 400. So the key here is a 1/5 increase. Now, a 1/5 is like 0.2, which is a 20% increase. So what does a 20% increase look like? Increase. 20% increase, to do that, you multiply the original by 0.2 and you add it to whatever you had before. So essentially, what you're doing is you're going to multiply number on Thursday times 1.2. And then you have the 1 there because the 1 keeps however many you had on the Thursday. The 0.2 is that 1/5 increase from that. So the number of students is 400 times 1.2. Or you could think of this as, or I could say, or 400 times 6/5. I'm going to be doing this without a calculator whatsoever, so it might be a little bit easier to work with fractions than with decimals if we're doing it by hand. 400 divided by 5, well, I think that's 80, and it should be 80, and 80 times 6 would be 480. So that should be answer choice A. Okay? Because that's a 5% increase. Yeah, that's a 1/5 increase. And by the way, I think we can look at the answer choices here. Yeah, see, here's the answer key. Yeah, look, see, number 1 is B, number 2 is A. Okay, good so far. Good so far. All right. By the way, I haven't practiced this prior. I'm doing this on the fly, so this is Mr. Spake's first attempt on this test. Okay, number 3. Last year, a bakery sold W loaves of bread. This year, the bakery sold 3 more than twice the number of loaves of bread sold last year. If next year, the bakery plans on selling twice the number of loaves of bread sold this year, how many loaves of bread does the bakery expect to sell next year? Okay, so you've got essentially 3 things here. You've got last year, you've got this year, and you've got next year. All right, so last year they sold W loaves of bread. And then it says this year they sold 3 more than twice the number sold last year. So twice the number of last year is 2 times W, and 3 more than that I would just add on 3. So next year it says, if the next year the bakery plans on selling twice the number of loaves sold this year, then how many loaves does this bakery expect to sell next year? So what we're looking for is the next year, and that is 2 times this year, which means I'm going to take that expression for this year. I'm going to do 2 times 2W plus 3, and that equals 4W plus 6. So the answer choice would be D. Okay? Be careful with this question because it's very wordy, right? This really requires that you think about the wording of it, breaking this into categories last year, this year, next year, because there's 3 things you're considering, and then making sure you're reading carefully about the comparisons between each year, right? For instance, it's not twice, right? Next year's bread isn't twice the number of last year. It's twice the number of this year. And this year is 3 more than twice last year. So be careful, okay? Careful. Take your time, all right? You'll have plenty of time on this test to do these 20 questions. All right. Let us scroll up to the next. Okay. Oh, my favorite, a classic Algebra 1 question. This is very basic single variable solving. Can you do a two-step algebra equation? Hopefully we say yes. So look, if I got 7p minus 4 equals 8, to solve for p, I need to use inverse operations to isolate that variable. Now you can do these in any order as you want as long as you're consistent with keeping the equation balanced. So because I see 7 times p, the inverse operation of multiplication would be division. So I know I need to divide by 7, and I'm subtracting 4, which means I need to add 4. Now, you could divide by 7 first, or you could add 4 first. It doesn't really matter, but adding 4 is the easier option. Reason being, if you choose to divide by 7, well, then you divide this guy by 7, this guy by 7, and this guy by 7, and then you're entering fraction territory. So if you can avoid fractions, it's usually, maybe preferable. So I'm going to add 4 to both sides. So I get 7p equals 8 plus 4, which is 12. One-step equation, divide by 7, right? So p equals 12 over 7. So that is answer choice C. Hooray! Okay. Move on to number 5. Running at an average rate of 6 miles per hour, how many minutes would it take Kyle to run 3 miles? Well, if I'm doing, let's see, it's 6 miles per 1 hour, which means if I'm running 3 miles, right, if I divide by 2 over 2, right? But essentially, you're thinking about cutting. If he's running, how do I explain? His average rate is 6 miles an hour. So cut that in half. That's his average rate for 3 miles, right? So it'd be 3 miles per 0.5 hours, which means how many minutes is 0.5 hours? It is 30 minutes. I think that one's pretty darn basic, so I hope I don't have to explain that too much more. You could pretty just logically reason what that's supposed to be. It's half an hour, right? If you run 6 miles in an hour, then it takes him half an hour to run 3 miles. Okay. Number 6. The dot plot above identifies the number of pets living with each of 20 families in an apartment building. What fraction of the families have more than 2 pets? So to figure out this fraction, we're thinking number of with 2 or plus, or sorry, wait, what fraction of families have more than 2 pets? Okay, so be careful with that. It's not 2 or more, it's more than 2. So say with greater than 2 pets. Okay, that's probably the thing that might be the most tricky about this question is don't include 2. It says more than 2 pets, not 2 or more. So be careful with that. And then we're just going to divide by total. Number total. I'm going to say total number. Okay. Okay, so the number of families with more than 2 pets is 1, 2, 3, 4. So this is equal to 4 over. How many are there total? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's 20. So if you say 4 divided by 20, right, that's like 4 over 4 times 5. So those cancel and reduces to 1/5. 1/5. And just to make sure that we got this right, let's see, 3 was D, C, B, B. Let's see this. D, C, B, B. Hey, look at that. We're good. Okay? So far, so good. We've done our first 6 questions. So, yeah. Let's move on to number 7. How fun is this? All right, the formula for the volume of the right circular cylinder shown is V equals pi r squared times height. That is the area of the circle that's either on the base or on the top, and you're multiplying the length of the height times that to generate the volume. Now it says if r equals 2b and h equals 5b plus 3, what is the volume in terms of b? So this is a very basic algebraic substitution. That's all this is. Algebraic substitution. I say v equals pi times r, which is 2b. So this is 2b squared. This is r squared. And then h is 5b plus 3. And maybe if I needed to make this very explicit, pi r squared h, then this, right. So I'll go ahead and square that. 2 squared is 4, so this is going to be pi times 4b squared times 5b plus 3. So let's distribute that. Now, when we do this distribution, I want you to keep in mind what we're doing is we're distributing this whole expression here and here. So when I multiply this out, I'm going to use the distributive property on that first quantity, 4 pi b squared onto 5b and onto 3. So let's see, 4 times 5 is 20, so this could be 20 pi b squared times b is b cubed. And then you do 3 times 4, which is 12, and then it's just pi b squared. And now there's just simple distribution. So we look for answer choice. Is it B? Yeah. Okay. Simple distribution. You know, just to make this very clear with my key, allow me to lasso this. I'm going to make this super clear. I'm going to pull that down here. So there's no doubt. It says V equals 4 pi b squared times 5b plus 4 pi b squared times 3. Okay? Now there should be no question as to how I did that. Okay. On to number 8. All right. Richard bought 3 slices of cheese pizza and 2 sodas for $8.75. Jordan bought 2 slices of cheese pizza and 4 sodas for $8.50. How much would an order of 1 slice of cheese pizza and 3 sodas cost? So this is a substitution elimination problem. This is a system of equations, which you always need to be able to construct. So we have a few goals here. We don't have a whole lot of space to do it in, but that's okay. We'll manage. Our goal is to figure out how much a slice of cheese pizza costs and how much a soda costs, and then figure out how much it would cost to buy 1 slice of cheese pizza with 3 sodas. So we're going to hold off on that question and set up the first system to solve. I'm going to use the letter C for cheese pizza, so it's going to be 3 slices of cheese pizza plus 2 sodas equals $8.75. And then 2 slices of pizza plus 4 sodas equals $8.50. Now, I'm going to multiply, so since this is substitution elimination, you could either, this is a system of equations, you can either use substitution or you can use elimination to solve this. I'll tell you right from the get-go that elimination is a much easier one to do. So I will multiply the top expression by -2, and this will come out to -6c minus 4s equals -17.50. And if you're wondering how I did that calculation, I doubled 8 to get 16, and then I doubled 75 to get $1.50, and so I added 16 plus 150. I did all that mentally. And, of course, it's multiplied by negative, so you have to keep the negative there. So I say 2c plus 4s equals 850. Now, the reason I multiplied by negative 2 on the top is so that negative 4s and 4s would cancel when added together. This is the elimination process. Now, negative 6c plus 2c is negative 4c, which equals, be careful with my math here, I think that's negative 950. Is that right? Be careful, Mr. Spake. I will use a calculator just to be sure. Only because I'm using a video. Oh, wait. It's 850, right? So it shouldn't be 950. It should be negative 9, right? Right? Is that right? I think so. Okay, yeah, calculator confirms it. Sorry, I forgot the 50 for a second. Now divide by negative 4 on both sides, so I get c equals positive 9 over 4, which is 2.25. All right. So if c equals 2.25, then, man, the one question they just did not give us space on, huh? All right. I'm going to change to blue here so it doesn't get too messy. 2 times 2.25 plus 4s equals 850. That tells me 4s equals, let's see, we're going to do a couple algebra 1 steps here. 2 times 2.25 should be 4.5, and I'm subtract 4.5 from 8.5, which should give me 4, which implies that s equals 1. So, if my last equation is, let's move to green. So I've got c equals 2.25 and s equals 1. Then 1 slice of cheese pizza plus 3 sodas. That's c plus 3s. That should be 2.25 plus 3 times 1, which is 3, which equals 5.25. And so that is answer choice B. Let's make sure I got that one right. Number 8 was B. Correct. Okay, so we are good. Okay, so you see that one was kind of lengthy. You had to, it actually asks quite a few things for you to do, right? It asks you to be able to set up those equations, to use elimination to solve for both variables, and then to use those variables to figure out a new expression, what that total is. Nice. All right, let's move on to number 9. If 5c minus 2 equals 3c, then what is 24c equal to? Okay. This is easy. Easy peasy. So I say, let's just solve this. 5c minus 2 equals 3c. This is another Algebra 1 question. Let's subtract 3c from both sides. So I get 2c minus 2 equals 0. And I'll add to the other side. So it's 2c equals 2. Therefore, c equals 1, right, by dividing by 2. And so then 24c equals 24 times 1, which equals 24. D. Is that right? Let us check. Number 9 is D. We are good to go. All right. Basic Algebra 1. Okay. Oh, goody, another Algebra 1 question. Oh, I love this. In the xy plane, the slope of the line y equals mx minus 4 is less than the slope of the line y equals x minus 4. Which of the following must be true about m? Well, if you're looking at y equals mx minus 4, and then y equals x minus 4, that's 1 times x minus 4. So what you're really looking at is m and 1, right? This is because m is the slope, right? M is slope. Y equals mx plus b. B is the y, sorry. B is not the b-intercept, it's the y-intercept. And m is the slope. So there you go. Okay? So if I'm comparing that to the slope of the line x minus 4, then I know that m needs to be less than 1. I think that this should be pretty straightforward. I don't know how else to explain this. Yeah, the slope of the line here is 1, and you want m to be less than the slope of that line. So therefore, m is less than 1. There's 10 numbers to choice C. Yes, it is. Okay. All right, number 11. The history class is made up of 12 10th graders and 9 11th graders. The 10th graders averaged 77 on the midterm exam, and the 11th graders averaged 91 on the midterm exam. What was the average grade on the midterm exam for the entire class? Okay, so this is an average problem, but it's a little bit more complicated than your typical average problems. Because, or your basic, I should say. A basic average problem would be just add up everything together and then divide by the total number. But this is a bit more complicated, just because you have to use the idea that there's 12 10th graders and 9 11th graders to multiply their averages. So essentially, the math on this one's going to look like this. It's going to be, look, there's 12 10th graders who averaged 77. So that's 12 times 77. That's going to account for the weight of those 77. Now, what this means, so I'm not a middle school teacher, so I don't know how they explain this exactly. But it's not saying that all 12 10th graders made a 77. It just means they averaged a 77. But to count for that weight of 12 of these people making a 77, you just multiply that average by 12, because that's how those 12 average out to be. So if you just multiply the average by 12, it's essentially the same as the sum of all their scores. Does that make sense? Right? Like, if somebody made a 90, and somebody made an 80, and somebody made a 70, and you divided by 3, I think the average should be 70, right? Or, hold on. Let's do that, actually. 90 plus 80 plus 70 divided by 3 is an 80, okay? So your average is an 80. Now, if you do 80 times 3, you get 240. But if you do 90 plus 80 plus 70, you also get 240. So see, if you just, it doesn't mean all 12 10th graders made a 77, but it does mean that the sum of those 12 10th graders' score adds up to 12 times 77. Okay? All right. Hopefully that makes sense. It's a little bit more complicated conceptually, but not very complicated mathematically. Okay, 9 11th graders, and we use the same idea that the 11th graders averaged 91. So we do plus 91, 9 times 91. Now, how many are there total, right? Let's see, there's 12 10th graders and 9 11th graders. Means that there are 19 total. Oh, sorry, not 19, 21, sorry. 12 plus 9 should get you 21 total students. Okay? And so I'm going to divide this by 21. All right. So say this equals, now, let's have fun with this. Let's think creatively here. How could we do this creatively? Look, you could use a calculator on this, but I told you Mr. Spake was going to do this completely by hand. And I want to do this creatively. So here's what I'm going to do. 12 is 3 times 4. So I know that this is 3 times 4 times, and 7 times 11 is 77. And then there's 9 times 91, so that's plus 3 times 3 times 91. So let's all divide this here. And actually, I just noticed something. 91, I think, is divisible by 7. Because if you do 1 here, you get a 7, and you minus, you get 21. That's 13. So actually, 91 could be split up into 7 times 13. So this is 21 down here. So what I want you to notice is there is a common factor here of 3 and 3 and 7 and 7. So what I can do is I can pull out 3 and 7 from this expression. I get 4 times 11 plus 3 times 13 all over 21. But of course, 3 times 7 is 21. So those cancel. And so I'm left with 4 times 11 is 44, plus 3 times 13 is 39. And let's see, so 44 plus 40 would be 84. Take away 1 is 83. This equals 83. And there we go. We've creatively done this without a calculator. Now, they might give you a calculator on this, so really you could just do the calculation. Also, there's no shame in just multiplying this stuff out, adding it together, and then using long division with 21. Both of those, all of those will work. But this is a way to creatively do it without really having to mess with too much arithmetic, really. Notice all I had to really do was notice that 91 was divisible by 7, and then I just factored some stuff out. So, yeah. Let's see. I'm gonna write that down. Factor out 3 and 7. That's what I did here. So you see that's algebra. That's what we did. We did a calculation using algebraic reasoning rather than just brute force calculation. Okay, anyway, let's move on. Which of the following is not equivalent to the quantity 3x minus 12 times x plus 4? Well, this isn't so bad, but it does require that you really think algebraically about this. So I'm going to try a few things, okay? The first thing I'm going to try is factoring out a GCF. So notice that 3x minus 12 equals 3 times x minus 4. So, I don't want this. I don't want the colors to conflict. So let's change colors. Let's do that. 3x minus 12 is equal to 3 times x minus 4. So 3x minus 12 times x plus 4 equal 3 times x minus 4 and x times x plus 4. Now, if you know that this is a difference of squares, right? A plus b times a minus b, then you know that this multiplies to be 3 times x squared minus 16. And that would be this answer choice. So it's not B, okay? It's not B. So let's change colors. Let's go to green. And if I multiply, right, if I have 3 times x squared minus 16, and I distribute the 3, then I get 3x squared minus 16 times 3, which is 48. So it's not answer choice C. I also can see that if I used distribution, if I said 3 times, oh, hold on, 3x, well, okay, no, not that way. Sorry. Not that. Rather, you see that 3x times x plus 4 and minus 12 times x plus 4 x plus 4 is the greatest common factor. So that equals x plus 4 times 3x minus 12, which happens to be what we started with, right? So answer choice D is kind of like the factor by grouping form of the original question, so it's not D. So by process of elimination, it would have to be A. And so we'll circle A. Okay? We'll circle A. Yeah. That was kind of tricky. You have to use a lot of factoring and distribution techniques to kind of eliminate your answer choices. I'm sure you could multiply. Another way to verify it probably is if you distributed this fella and you distributed this fella, you would see that those results are not the same. Okay? So could we write that somewhere? Here, I'll do it for the video. I just won't keep it on the document. All right, I'm going to do this one in gold, just so you can see what I'm talking about. Just another strategy you could have tried. If you did 3x minus 12 times x plus 4, and you distribute this, 3x times x is 3x squared, plus 12x, minus 12x, and then minus 48. Okay, sorry, I had a brain fart there. 3x squared minus 48. Versus, if you take 3 times this business, you do 3 times x squared, so that's 3x squared, minus 24x plus 48 by distributing that last one. And you would see that this and this are not equivalent. So because they're not equivalent, you've essentially compared both equations in standard form. It says those standard form equations are not equal. That answer choice would not work. Okay? And then you might just have to say gut instinct says that B, C, D have to be correct, unless you want to verify it like the way we just did. All right. Let's continue. If the cost of carpeting a floor is $2.50 per square foot, how much will it cost to carpet a rectangular floor that is 10 by 10 by 12 feet? Really? Okay, I'm just making sure I'm not overthinking this. So a 10 by 12, right? 10 foot by 12 feet gives you okay, so that's, oh my God. Okay. 10 foot by 12 feet equals 120 feet squared, right? It's per square feet. So then I'm going to, if the cost of carpeting a floor is $2.50 times square footage, then I'm going to do $2.50 per square foot times 150 square feet equals, well, that's if I double if I double 120, that's 240, and if I cut 120 in half, that's 60. So it's 240 plus 60, because that's right, that's the 2 and the 0.5, and that's going to equal to $300. That'd be our units here, $300. So it's answer choice D. Okay? Let's make sure we're doing okay here. 11 was BAD. Good stuff, good stuff. We're good. We're doing good. Okay. Ooh, I like these. If n is the least of two consecutive odd integers, which of the following represents the sum of the two integers? Oh, I love these questions. These are so much fun. Be careful here because of this word consecutive odd integers, right? Here are some examples of consecutive odd, right? Consecutive odd integers. consecutive means in a row, right? So like 3 and 5, 7 and 9, 121 and 123, right? Those are some examples. Now, if n is the least, then you would start with n, and then how would you find the next odd integer? Well, you'd increment it by 2, right? Because I'd say 3 plus 2 is 5, 7 plus 2 is 9, 100, right? So say 3 plus 2 equals 5, 7 plus 2 equals 9, 121 plus 2 equals 123. So then n plus 2 equals the next number, n plus 2. So it'd be n plus 2. So those are the things I'm adding, right? Now, it says represents the sum of the two integers. So the sum would be the first integer, n, plus the other integer, n plus 2. And that comes out to 2n plus 2. So it's answer choice D. Let's make sure 14 is D. Hooray! Okay. Moving on to number 15 here. Okay, now looking at 15, you know, I'm not sure whether this is covered in Algebra 1. I know it was covered in my Algebra 1, but state standards have changed since I was in high school. Not that I'm an old bag or anything, but, you know, things have changed in the last 10 years, so, I don't know whether this is an Algebra 1 or Algebra 2 topic. Maybe it's both, maybe it's just 1 or 2. We will cover this in the spring semester of Algebra 2, but because these deal with negative exponents. Now, if you've never dealt with a negative exponent in your life, here is the basic gist. I'm going to do this in gold since this is new. Negative exponents. So the basic gist of a negative exponent is that x to the power of negative 1 equals 1 over x. Or rather, maybe more generalized. The more generalized thing I should say isn't just that. It's x to the power of negative n equals 1 divided by, oh my gosh, can't type, or right, 1 divided by x to the power of n. This is how we define negative exponents. And just to illustrate this concept for you, in case this is the first time you've seen this, the idea is, let's say I had x to the power of 6 divided by x squared. The way you would calculate this division is you say, oh, well, the x to the power of 6 is x times x times x times x times x times x. And then x squared is x times x. And then they have common factors here, right? X and x, x and x. And so what is the result? X to the power of 4. And we learned in Algebra 1 that to divide these things, you subtract the exponents, right? So a shorthand for all of this business really is just to take those exponents, x to the power of 6, minus 2. So you get x to the power of 4. Hooray, right? But suppose I flip this on its head. So let's flip this around. Let's say that it is x to the power of 3 divided by x to the power of 5. Well, then that's x times x times x over x times x times x times x times x. And then if I just cancel out the things that they have in common, I'm left with no x's, so there's only 1 up here, over x times x, which is x squared. And if I was doing subtraction of exponents, I'd say x cubed minus power 5, that's equal to x to the negative 2. So therefore, x to the negative 2 equals 1 over x squared. So all of this is example. Okay. So here's how we deal with this problem. Okay, because maybe you've never seen that negative exponents before. If you have, then you know how this works. So x to the power of negative 5 y over y cubed. Forget this power of negative 1 up here for a second. I'm just looking at the argument inside those parentheses. If I do that, well, I say, well, x to the negative 5 is equal to 1 over x to the 5th. So this equals y over x to the 5th y cubed. And I notice that there is a y on top. So if I actually rewrite this as y cubed is y times y times y, then those y's cancel. And so I get 1 over x to the 5th times y squared. So now what I have, right? So now this is 1 over x to the 5y squared to the negative 1. Is this thing, right? And so to do this, I just flip the fraction. You could think of this as you distributing 1 over x power of negative, right? So this is just x to the power of 5 y squared. This would be answer choice C. So number 15 is answer choice C. Yes, correct. Okay. I just talked about this one a little bit because I don't know how many of my students know negative exponents. Maybe you know them and then this was super easy and you're done. If you haven't seen them before or if you don't remember them very well, I'm not going to do too much more of a review of it here. So please go take a Google search and review what negative exponents are. Because I think I did a good job of explaining this process and this stuff in red, but you might, maybe, you're hung up on how I did that last part in blue, which I don't really want to explain in this video right now. But essentially, I guess you could also say if x to the negative n equals 1 over x to the n, I could say also 1 over x to the negative n equals x to the n. Okay, because that's the other kind of property. If I have it's essentially if you have a negative exponent in the numerator, you put that in the denominator. If you have a negative exponent in the denominator, you put that in the numerator. That's essentially it. I just kind of flipped the fraction. Okay. Only 4 more. We're almost there. Okay. Number 16. Raina has 5 coins worth 10 cents each and 4 coins worth 25 cents each. If she chooses 2 of these coins at random, what is the probability that the 2 coins combined will be I can't speak. What is the probability that the 2 coins combined will be worth at least 35 cents? Okay. Raina has 5 coins worth 10 cents each and 4 coins. So the only way this is going to happen is if she gets a if she gets a dime and a quarter. By the way, the reason they usually how do I explain this? So like if you're not from America, you may not understand that a dime is 10 cents and that a quarter is 25 cents. And since these kinds of tests are used with under the idea that anybody, not just Texans or Americans, could take this test, they kind of specify 10 cents each and 25 cents each. So we know that those are dimes and quarters, but if I asked you a problem in terms of pounds and shillings, would you know which is what, right? So that's why they're calling it 5 coins worth 10 cents each. Anyway, I think the way you do this, I got to be careful here. I don't want to tell you something wrong. Is it, because I need 1/5, and I need to multiply that by no, that's not right. Wait, Mr. Spake, how do you do this? She chooses 2 coins at random. It's not a 4th plus a 5th, is it? I feel like I'm blinking. I feel like I've... this is, so you see, Mr. Spake isn't perfect. There's one thing Mr. Spake forgets a lot in math, and that is probability and statistics. Even though he has taken countless probability and statistics classes, when I'm in the class, I get it. But this is not a skill I've practiced very often, and so often I just kind of blank on these questions. So you see, it even happens to your teachers. What's the probability that you pick a coin worth 10 cents? I feel bad. Because you know what I'm going to do? I'm going to look at the key. Because I got that. Okay. Worth 10 cents. Wait, what? The only way the 2 coins Raina chooses could not be worth at least 35 cents combined is if both coins are worth 10 cents. Oh, no, because, yeah, okay. Oh, because it's at least 35 cents. Oh, Mr. Spake, you're blanking. You see? Ugh. For this to happen, the first coin Raina chooses, and the second choice must be 10-cent coins. It says 5. If the first coin chosen is a 10-cent coin, there will remain 4 coins worth 10 cents each, and 4 coins worth 25 cents each. I see. I've never liked these. Actually, that's not true. I actually love these problems because they make me think critically. I'm going to come back to number 16 and kind of try and explain that again. I don't know. This is the one type of math Mr. Spakes admits he needs to keep improving on. Because I always get stuck. I always take long on these. So just know that you're not alone. And don't think, oh, if my math teacher can't do it, I can't do it. Yes, you can. You can reason through this just like I can. Just take some thought and practice, all right? I know Algebra 1 and Algebra 2, Pre-Cal and Calculus much better because I've used that a lot more than I ever have probability. But that's not to say probability isn't important, right? If I were in the realm of stats more often, I would know it better. Okay. In the xy plane, what is the y-intercept of the graph of this equation? Okay. Yeah, that's you want to be careful with that. There's actually 2 ways you can do this. So 2 ways. So I'm going to say method 1. Plug in x equals 0. This is the easiest way, okay? This is the easiest way because all y-intercepts are going to occur when x equals 0. So if I do that, then y equals 6 times 0 minus a half times 0 plus 3. And so that is 6 times negative half times 3. So that is negative 3 times 3, which is negative 9. So it's answer choice A. So 17 is A. Correct. Okay. I'm going to show you method 2, though, real quick. If you distribute this into standard form, so here, just if you would just give me 1 second. Distribute this. So I'm going to distribute the 6 real quick. Say this equals 6x minus 3. This is x plus 3. And then I'll distribute this. 6x times x is 6x squared. And then 6x times 3 is 18x. And then negative 3x. And then negative 9. And actually, you don't even have to do all that, by the way. You just have to do the last combination. But if you distribute this, this fella is the y-intercept, because ax squared plus bx plus c is the y-intercept. So that's how you could also do it. And which, by the way, if you really, really, really know your quadratics well, all you had to do was 6 times negative a half is negative 3 times 3 is negative 9. And that's actually the quickest way to do this, I think, is having that strong understanding of the distributive property, knowing that you're just looking for the product of the constant terms. So you take that lead coefficient there, 6, you multiply that by negative a half, you multiply that by 3, because those are the product of the constants. And that's all you're looking for. So, but that would demonstrate true mastery, I think, of that problem. Okay. On to number 18. We're getting into some quadratics here. Area of a triangle above is 21. So what is the value of x? Well, the area of a triangle is 1/2 base times height. So then this is 1/2 times x plus 1. Which means, so the area of this triangle is 21. Let's multiply everything by 2, so I get 42 equals x times x plus 1. And then I'll distribute that, so it says 42 equals x squared plus x. And then this is just quadratics. So the question is, how do you solve this quadratic equation? Put it in standard form, set it equal to 0. So I'm going to subtract 42 from both sides and say x squared plus x minus 42 equals 0. Now factor this, so it's x plus 7 and x minus 6 equals 0. Therefore, your solutions are x equals negative 7 and positive 6. But of course, length can't be negative. Length not negative. So x equals 6. Answer choice B. And that is number 18. Yes. Okay. All right. So yeah, basic gist, I know I worked through that one a little bit fast, but the basic idea is area of a triangle is 1/2 times base times height. And then when you do that, because both the length and height in terms of x, this creates a quadratic. And to solve quadratics, you really just set the equation in standard form, set equal to 0, and then you factor or use quadratic formula or complete the square to solve for the zeros, to figure out what the solutions are that make that equation true. Okay? All right, let's look at number 19 here. For which of the following values of x is the function f of x equals root of 4 minus x squared not defined as a real number? Well, let's see. Non-real numbers are the square root of negatives. So when is 4 minus x squared negative? we're essentially looking for when is 4 minus x squared less than 0. That's the inequality you're trying to figure out. Now, I'll tell you this. Because they have answer choices, you can just test each answer choice, right? So I'll say that option 1, test answers. So if x equals -2, this is answer choice A, then 4 minus -2 squared, that's 4 minus 4, that's equals 0, which is not less than 0. So it's not A. If x equals 0, then it's 4 minus 0 squared, which equals 4, which is not less than 0. So it's not B. If I say x equals 2, then it's 4 minus 2 squared, which equals, again, 4 minus 4, which equals 0, which is not less than 0. So it's not answer choice C. So then it must be x equals 4, which is 4 minus 4 squared. That's 4 minus 16. That's -12, which is less than 0. Check. So it is D. Option 2, let's say option 2 would be to actually solve this inequality. 4 minus x squared is less than 0. When does this happen? Well, 4 minus x squared is the difference of squares identity. So this is 2 minus x, 2 plus x. And we're looking at this less than 0. And so you could create a number line out of this where the roots are +2 and -2. And then you just need to test the regions. So if x equals 0, then you do 2 minus 0 times 2 plus 0. That's just positive times positive equals positive, which is greater than 0. So this does not satisfy it. And then you could test x equals 3. And so you'd say 2 minus 3 times 2 plus 3 would equal -1 times 5, which equals -5, which is less than 0. So that's check. So I'd say check, and it'd be this way, and I have a hole here. And so then you could test x equals -3. You get the same thing, 2 minus -3 times 2 plus -3 equals essentially the same thing, right? 5 times -1 is -5, less than 0. Check, and say that this matches it. So this checks out. So your region is from -infinity to -2 union to infinity. And that's the region that satisfies the inequality as to when this is going to be negative. So you look at your answer choices again, and you compare -2, 0, 2, and 4, and -2 is not in there, 0 is not in there, 2 is not in there, but 4 is in that region. So you'd say answer choice D is 4. So notice what I did in blue, option 2, is a lot more complicated because it involves actually solving that inequality and then finding the sort of the domain of x that satisfies that inequality, and then looking at your answer choices to see which one of those falls within the domain. I like that approach because it's very mathematical, very theoretical, and very accurate. But I will say, as far as test-taking strategies go, for this one, it's so much easier to just test the points, all right? Test the answer choices, plug them in, there you go, all right? I will be honest, that is the more efficient way to solve this problem for test-taking purposes. But I think option 2 is a tad more elegant, right? It's a tad more sophisticated, and I think more pleasant than option 1. But that's fine. It's whatever. Here nor there. Okay. Last one's number 20. Under ideal conditions, the population of certain species doubles every 9 years. If the population started out with 100 individuals, which of the following expression gives the population of the species T years after the population has started, assuming that the population has been living under ideal conditions? So you double every 9 years. So the way you do this, how do I explain exponentials? So for exponentials, say my initial amount times my sort of like rate of growth to the power of time. All right, that's kind of how that's the gist of how exponentials work. This is in between an Algebra 1 and an Algebra 2 problem. You should have covered this in Algebra 1, but you really master exponentials and problems like this in Algebra 2, which means you might be able to figure this question out now, given that you've taken Algebra 1, but by the end of Algebra 2, you certainly should be able to answer this question. So if I start with my initial amount, is 100. So already that gets rid of answer choice A and B. And now the question is, well, my rate of growth, well, I'm doubling. So that equals 2. So this is 100 times 2. The only question is time. Now it doubles every 9 years, right? Doubles every 9 years. So if I said 2 to the t, that would be doubles every year. But I don't want to double every year, right? I want to double every 9 years. So I will get to that 2 if I do t to the power of 9 over 9 would equal 2 to the power of 1, that's your double. So essentially you're going to take your number of years and divide it by 9, because that's how long it takes to double. I don't know if I'm doing the best job of explaining that. Should be answer choice D. Yeah, it is. So it's answer choice D. How can I explain that better? I don't know if I'm doing the best job explaining that. So it's the initial amount times your rate of growth to the power of time. Time being, it's that 2, you're going to multiply it by 2 every 9 years. So you don't want to do 2 to the power of 9t, because if t was 1 year, right, if 1 year passed, that'd be like multiplying by 2 to the power of 9. And that is way too much, right? That's not what's happening. So you're going to multiply by a smaller amount than that. But once 9 years occurred, that 100 is going to become 200. All right, so you could think of this as like after 9 years, 100 should double to be 200. So if you compare option C, 100 times 2 to the 9 times 9, right? That's 100 times 2 to the 81. Whoa, that is not 200. But if you answer choice D, 100 times 2 to the 9 divided by 9, that's 100 times 2, which is 200. Maybe, hopefully that explanation does a little bit more service for answering this question. Okay, I hope that helps. Okay, so that's pretty much all of them, meaning I think Mr. Spake would have passed the TSI, assuming he did not need to get all 20 correct. Because number 16, that one is tricky. So let me try to explain this one, given that I read the description. This one's very tricky because of this wording here at the end, worth at least 35 cents. And the key focus is on this term, at least. At least implies quite a lot. With probability, whenever you see something like at least or at most, you can think of it either in terms of the possibilities that satisfy that, or you could think of it in the terms of possibilities that don't meet that, and then kind of think about the total number of possibilities and take it away. I don't want to explain too much. So, look, if you're just looking, okay, if she chooses 2 of these coins at random, what's the probability that they'll be worth at least 35 cents? Well, only time it won't be 25 cents, or sorry, 35 cents, is if she picks 2 10-cent coins. I'm going to write 2 as 2 10-cent coins. So if you multiply, you would just think about probability of picking a 10-cent coin. Is that it? Hold on, I gotta look at the stupid answer. This one's hard. This one's making my brain think. I'm so glad that the answer choice is here, because honestly, I don't know if I could explain this on my own right now. I'd have to give it way more thought than that's due for the video. For this to happen, the first one must be each 10 cents. Since 5 of the coins are worth 10 cents each. Yeah. So see, there's 5 coins and 4 coins, so there's 9 coins total. So the probability of picking 10 cents is the number of 10 cents divided by the total. So that's equal to 5/9. And then if you have the probability of picking not 10 cents? No. I guess you'd say probability of 10 cents again, right? Yeah. Because there'd be 4 remaining. Yeah. And so the probability of 10 cents again would be number of 10 cents over total, which would be 4/8. Right. So the probability of picking 2 10 cents is 5/9. Oh God, there's just not enough space for this. There's so much. 5/9 times 4/8. But that's just 5 times a half, right? So that's 5/18. And you got to do 1 minus 5/18 to get 13/18. C. Okay. Yeah, so I get it. I probably could have figured that out if I don't know. I'm under pressure because I'm filming a video, and so not knowing how to do it, I freaked out. Just like a lot of you freak out when you have a test in front of you, which, see, it happens. I understand. I'm with you. I get it. I totally get it. Okay, so let me try to explain this one more time. You're looking for the probability worth at least 35 cents. But the thing is, that's a lot of work to do to figure out how much are worth at least 35 cents because there's fewer combinations of coins that make less than 35 cents. And that combination is picking 2 dimes. So if Raina picks 2 dimes, that fails. Any other thing she picks, if she picks 2 quarters or if she picks a dime and a quarter, then she's okay. But if she picks 2 dimes, that's not going to satisfy this. So essentially what we do is we find the probability of her picking 2 dimes and we subtract that from 1. And to explain that, so probability always adds up to 100%, which we use 1, right? Because, we do fractions as less than 1. So 100% is 1. So you essentially take 1 minus the probability of the event not happening. That tells you the probability of the event that is happening. So I might write that up here. Probability of event not happening. That is equal to 1 minus the probability of an event happening. That is because the sum of probability equals 1. So right, if I have some probability of an event happening and I add that with the probability of it not happening, well, that's the thing. Only one of the two could occur, right? Either it happens or it doesn't. So that equals 100. That's your total. It adds up to 1. So if you subtract from when it is happening, or vice versa. Sorry, I should have said probability of event happening. This one would be not. Actually, both are true, but this is the one we did. I did 1 minus the probability of the event not happening. You could also find this probability by finding the probability that she picks 2 quarters, and adding that with the probability that she picks a quarter and a dime. So actually, to show this one more way, maybe, so I guess alternate solution might be, so the probability that she picks a quarter would be 4/9, and I'd multiply that by the probability that she picks another quarter, which would be 3/8. And if you're saying, where is he getting these? So there's 4 coins that are quarters, right? So the probability that I pick the first quarter is 4 out of 9. But since I've picked a quarter, there are now 8 coins remaining, not 9. There's 8 coins remaining. And since I picked a quarter, only 3 quarters are left, not 4. So I could multiply those probabilities together. And then I could add the event that I pick a quarter times the event that I pick a dime. And so if I pick a quarter, that'd be 4/9 times 5/8. And this would come out to, let's see here. I'm doing some mental math here. That's a half. That's a third. So that's a sixth. Plus, that's a half. So that's 5/18. Is that right? Oh, but then you'd have to add the probability that she picks a dime first. Yeah. Oh. This is the reason you don't want to do it this way, because it gets too much. If I added the probability that she picked a dime, that'd be 5/9 times the probability that she picked a quarter, that'd be 4/8. So it's that one again, which is another 5/18. And so that's 3/18 plus 5/18 plus 5/18, which equals 13 over 18. Answer choice C. Okay. Yeah. So you add all those probabilities together. That one is even more complicated to explain. Both are complicated to explain. I'm very curious as to where this lies in our curriculum, because we don't really cover probability here. I guess it could be covered in stats. Maybe you did this in middle school? Okay, I'm sorry. I'm rambling on for too long. The video is it's going to take half of this video. It's just going to be me talking about number 16, because probability has so much to it. But whatever. We got the answer, and we got it 2 different ways. And there you go. So I'm satisfied. I am a little ashamed that I looked at the answer key. I probably could have figured that out on my own and been a good role model for you, showing, even when Mr. Spake struggles, he can get it on his own, but whatever. Sorry, had to do this for the sake of time. Didn't want to be here all day. Anyway, hope you enjoyed the video. Hope you enjoyed seeing this. I hope it was helpful, and good luck on your final exams.